In 1911, Australian geologist Thomas Griffith Taylor was exploring the remote valleys of Antarctica when he stumbled upon a strange sight, a blood-red waterfall gushing from the snout of a glacier. Taylor first suspected the unusual color was caused by red algae, but he was unable to collect any samples to confirm this theory. Little did Taylor know at the time, but he had inadvertently uncovered one of Antarctica's most enduring mysteries. Antarctica is a land of ice and snow, but also of secrets and mysteries. It is a frozen continent at the bottom of the Earth. It's the coldest, windiest, and driest continent on Earth. Despite its harsh conditions, Antarctica is home to diverse wildlife, including penguins, seals, and various seabirds. One of the most intriguing phenomena on the frozen continent is the Blood Falls, a red-colored waterfall that flows from Taylor Glacier into the West Lake Bonny. But what causes this strange, creepy waterfall to look red? Does it reveal about the hidden life beneath the ice? Let us dive deep into this intriguing mystery. In the 1960s, studies began to determine the origin of this mystery. Researchers found trace amounts of iron-rich minerals like magnetite and hematite in the water. The characteristic red hue of many rocks and mineral springs, often caused by these types of minerals exposed to weathering. However, the concentrations detected were far too low to fully explain the depth of the Blood Fall's color. Another hypothesis involved a thick bloom of red pigmented algae within the melting glacier ice, but there was no conclusive evidence for this either. Scientists noted that the red discharge seemed to intensify over the summer. Historical accounts describe the color starting as a lighter yellowish-orange before becoming a deeper red over time. Mineral analyses detected compounds like aragonite, quartz, feldspar, and small quantities of magnetite. The breakthrough came in 2009 when a research team led by microbiologist Jill McCookie from the University of Tennessee conducted a study on the Taylor Glacier. McCookie's team made the astounding discovery of 17 different types of microbes thriving in the ultra-cold, oxygen-deprived lake under the glacier. These bacteria had adapted to survive the extreme subglacial environment of total darkness and freezing temperatures. They sustained themselves in this nutrient-deprived environment through a process called chemosynthesis, in which they obtained energy by breaking down the sulfate and iron in the water. By mapping all the glaciers, caves, and rivers in that area, the researchers determined that the reddish brine was being originated from a massive ancient seawater reservoir, which is about 5 million years old, trapped under the Antarctic ice. This reservoir is rich in dissolved minerals that accumulated as the glacier moved across rocks over time. Their research revealed that the briny water in this subglacial reservoir is extremely cold. It is also highly saline, containing about 8% sodium chloride. Around 5 million years ago, during the Miocene epoch, the area was connected to the ocean because sea levels were higher. As the glacier grew over time, it isolated and froze around some of the seawater. When the seawater froze, salt and other impurities were expelled from the ice. This created a very salty, concentrated brine that could not freeze, even in Antarctica's extreme cold temperatures. While solving part of the mystery, discovering life in the brine only deepened questions about the Blood Fall's red coloration. By analyzing samples of the brine under transmission electron microscopes, researchers detected countless tiny spherical particles, just a few nanometers in diameter. These minuscule nanospheres lacked the crystalline structure of typical minerals. Using X-ray analysis, the team characterized the nanospheres as amorphous particles composed of iron, silica, calcium, aluminum, sodium, and other elements. When the iron-rich nanospheres make contact with air, they oxidize to produce iron oxides and hydroxides, staining the water a striking shade of red. The oxidized iron wasn't acting alone either. Other components like chlorine, magnesium, and sodium likely contributed to the yellowish-orange hues seen in the outflow fan. This multi-elemental makeup of the nanospheres finally explained the evolution of colors reported from the falls over time. The discovery of microbial life in the extremely harsh environment has exciting implications for astrobiology. The subglacial conditions of total darkness, freezing temperatures, lack of oxygen, and mineral-rich waters are similar to conditions that may exist on other icy worlds like Europa and Enceladus. Both of these moons, orbiting Jupiter and Saturn respectively, are thought to have subsurface liquid water oceans that could potentially host life if hydrothermal vents are present on their seafloors. They could provide the energy and nutrients to support hidden ecosystems. Just as the brine nurtures microbes under Antarctica's ice, Blood Falls is not only a natural wonder, but also a natural laboratory for studying the origins and limits of life on Earth and beyond. I hope you like this video. Don't forget to subscribe to our channel for more detailed explorations into the mysteries of the universe.